morning. I hope all of you are doing well. I got a question about question number 9 from JE, and I'm going to answer it now. And I can consider this an introduction to today's lesson. Okay. So question 9 says, find derivative expression for cosecant x and secant x. So actually, it is the same protocol that we are going to use. So I can say if y equal cosecant x, we don't know how to find the derivative of cosecant yet, but we know that cosecant is the reciprocal of sine. So I can write this as y equal 1 over sine x. By the way, I have posted a trig identity sheet in your HB page, so please download it. It will help you with all of these process. So cosecant x is 1 over sine x. Now we can find the derivative of this. There is two ways I can write this. So I will do this one with quotient rule. I will do the other one with I will send this up and change the sign. So when we come to secant, we'll do it in a different way. But both of them are valid for this and that. So now if I want to find y prime, I can use quotient rule, which is low squared, low, d high, minus high, d low. Okay, so y prime will equal sine x times 0 is 0. That will leave negative cosine x over sine squared x. This is, I can leave it like that, but there is something better we can do. So we can write this as negative cosine x over sine x times 1 over sine x. Right? If you multiply those, cosine x times 1 will give you negative cosine x times 1 will give you negative cosine x. If you multiply sine x times sine x, that will give you sine squared x. So this is equivalent to this. This 1 over sine, so not minus 1 over sine is cosecant. So I can, or this is cotan, cosine over sine is cotan x, and 1 over sine is cosecant x. So this is the derivative of cosecant x. Alright, with the same principle, with the same idea, I will find the derivative of secant x. Again, I don't have an expression for secant x, but I think orange, this is, yeah, red. I can write y equals secant x as y equal 1 over cosine x. Then I told you I will do this in a different way. I don't have to use quotient rule. I can write this as 1 times cosine x to the power of negative 1. I took this from down to up and changed the sign of the exponent from 1 to negative 1. Now I will use chain rule. So y prime will equal the negative, this is g of x to the power of n, so n g of x to the power of n minus 1, so negative 1 minus 1 is negative 2, times g prime of x. Derivative of cosine x is negative sine x. Now I can multiply the negative and the negative, so that will be positive, and I can take the cosine squared negative cosine x to the power of negative 2 to the denominator and make it cosine squared x, and on the top that will leave sine x. And with the same protocol, same thing we did here, we can write this as 1 over cosine x times sine x over cosine x. 1 over cosine x is secant x. Sine x over cosine x is tan x. So this is the derivative of secant x. So the derivative of secant is secant tan, derivative of cosecant is negative cosecant cotan. Okay? So this is question 9 from yesterday's homework, and I will start today's lesson immediately. We are going to learn today the derivative of tan x. So if f of x equal tan x, let us say y equal tan x, and I want to find derivative expression for that. The first thing, I can write tan as sine x over cosine x. All of us know that from grade 10, and it's also in your sheet. Now to find the derivative, I will use the quotient rule. Quotient rule says low squared, so cosine squared x, low d high, so cosine x times the derivative of sine x, which is cosine x, minus, I always like to open bracket after the minus, high, d low, the derivative of cosine x is negative sine x. So what we are going to get is cosine squared x plus, minus is plus, and sine x times sine x is sine squared x over cosine squared x. All of you know, when we see this, we are lucky because this can be simplified to be 1. Sine squared plus cosine squared equals 1. So this is 1 over cosine squared x. And 1 over cosine is secant. So 1 over cosine squared is secant squared x. So the derivative of tan x is secant squared x. Okay. Now we're gonna use this in our questions. So again, all the rules that we learned in sine and cosine, so y equal tan x, y prime equal secant squared x, y equal tan f of x, y prime will equal secant squared f of x times f prime of x. Same rules that works for all the functions. If we have tan to the power of n f of x, and we need to find the derivative of that, this will be n tan to the power of n minus 1 f of x times f prime times the derivative of the tan, which is secant f of x times the derivative of f of x, which is f prime of x. We're gonna see this practically when we do questions now. So those are the rules. I will start with example. Let us say y equal tan x squared plus 3x, and we need to find the derivative of that. So this is in the form of y equal tan f of x. So y prime will equal the derivative of tan anything is secant squared that thing times the derivative of whatever between the brackets f of x. So times 2x plus 3. That's it. You can put this in the front if you like. 2x plus 3 times secant squared x squared plus 3x. So this is the derivative of this function. Okay. Example 2. Y equal sine x plus tan x to the power of 4. This right away remind me of g x to the power of n. So I'm going to use the chain rule. So n, I can use different color. So n, g of x to the power of n minus 1, that will be 3, times g prime, the derivative of this. What's the derivative of sine? It is cosine x. What is the derivative of 10x? It is secant squared. That's it. Okay? Alright. Let's do example 3. Y equal x tan 2x minus 1. This is definitely product rule. Two functions multiply together. So y prime will be first times derivative of the second. Derivative of tan anything is secant squared that thing. Then derivative of f of x, so that's 2. Plus the second times the derivative of the first, which is 1. So we can write this in a better form. 2x secant squared 2x minus 1 plus tan 2x minus 1. And we are done. These are the questions. Yeah, actually we are done. So this is the questions. I want you to do page 260. So the homework for today, page 260, number 1 to 4, and number 10 and 11. So number 1 to 4, yeah, and number 10 and 11. Waiting for your feedback. Please tell me if you have any questions, and we are almost finishing this unit. I just want to spend some time with word problems and optimizations, but so far we are doing very well. Alright, waiting for your questions, and see you soon. Bye.